Hey guys, let's work on one of my favorite topics in math, which is solving logarithmic and exponential functions. It's fun and it's easy. So let's start with one of an exponential equation. I have 3 to the power of x equals 81. Now, if you have an equation like this, you have to think, can you write that number as a power of 3? Yes, 81 can be written as 3 to the power of 4. 3 to the power of x equals 3 to the power of 4. The reason why we did that is because if we can make the bases same, we can get rid of the bases and say the power x is equal to 4. So here the bases are same. We can say x is equal to 4. Done. Okay. Now let's look at one more problem similar to this. 3 to the power of x plus 2, or sorry, 3 to the power of x plus 4 equals 243. Now you have 3 to the power of x plus 4, and here you have 343. Now if you're not sure if that can be written as a power of 3, you can make your factor tree and come up with the factors. So 243, we know it's 3 times 81, 3 times 27, 3 times 9, 3 times 3. So that's 1, 2, 3, 4, 5 threes. 3 to the power of 5 is equal to 3 to the power of x plus 4. Now the bases are same. You can say x plus 4 is equal to 5. Inverse operation, subtract 4 on both sides, you get x equals a 1. Okay, let's move on. Let's deal with some fractions here. 1/2 to the power of x equals 8. Now, I have 1/2 and 8. So I can write this 1/2 as 2 to the power of negative 1 to the power of x equals 2 cubed. Now the bases are same. Multiply the negative 1 and the x, you get negative x equals 2 to the power of negative x equals 2 to the power of 3. The bases are same, powers must be same, so you get negative x equals 3, or x equals negative 3. I'm having a lot of fun. Let's move on. Number 4. Okay. Oh, this is a fun problem. 2 to the power of x equals 2.75. Okay. Now, that number cannot be written as 2 to the power of some whole number. Now, what do we do? How do we solve it? We did a similar problem when we introduced logarithms. And I told you that if you have problems like this, you have to use logarithms. So how do we use logarithms? So if you have an exponential function where you cannot make the bases same, then what you do is you apply log to both sides. So you know you can take square root on both sides. You can add a number to both sides. You can subtract a number on both sides. You can apply log on both sides. So let's do that. So we'll apply log to base 10, or common logarithm, on both sides and say log of 2 to the power of x equals log of 2.75. Okay. Now, you know your properties of logarithms. Here we have log 2 to the power of x. We can use our power rule and move that exponent in front of the log. That gives you x log 2 equals log 2.75. Divide by log on both sides. We are just using inverse operation now, because this was x times log 2. So we divided by log 2. Now this is where we need our calculator. Let's grab one. Okay, so log of 2.75 divided by log 2. That's 1.459. So let's write an approximate value and say x is approximately 1.5. Okay, done. Okay, so we did some exponential equations. Now let's try to solve some logarithmic equations. Okay, let's say you have log, this is my fifth problem, log of 2x minus 4 to base 2, or log base 2 of 2x minus 4 minus log base 2 of 8 equals 0. Okay, now I see that both the logs have the same base, and I have a minus sign here. So if I add log base 2 of 8 on both sides, I'll have log on both sides, then it becomes easier for us to solve. I'll show you how. Log base 2 of 2x minus 4 is equal to log base 2 of 8. Okay, now you see you have log base 2 on both sides. You can apply log to both sides like we did in the earlier problem, or you can cancel log on both sides. So if you do that, you get 2x minus 4 equals 8. Okay, we got rid of the logs on both sides. Now we have to solve for x, add 4 to both sides, use inverse operations. That gives you a 12, x equals 6. Okay, number 6. Let's say we have a quotient here, log of 5x minus 1 divided by log of 29 equals a 1. Now, we can multiply by log 29 on both sides. That way we'll have log to base 10 on both sides, or common logarithm on both sides. We can get rid of the logs and solve for x. Let's do that. So multiply by log 29 on both sides. You can say multiply by log 29 on both sides, or do cross multiplication. Okay, same thing. Log of 5x minus 1 equals log 29. You have same logarithms. You can get rid of the logarithms and say 5x minus 1 equals 29. 5x equals a 30, or x equals 6. Okay. Log x equals 3.67 is our next problem. Okay, now I don't have two logarithms. What do I do? If you have a problem like this where you have just one logarithm on one side and a number on the other side, the easiest way would be to change it to exponential form. Okay, how do we change it to exponential form? We know that the base here is 10. If there is no number, that means the base is 10. So if I have a base 10 here and we want to change it to exponential form, this would be 10 to the power of 3.67 equals x. Okay, or x is equal to 10 to the power of 3.67. Okay, We need our calculator for this. Okay, let's put this in the calculator. 10 to the power of 3.67, which is 4,677.4 approximately. Okay, that was fun. Okay, so we did different types of exponential and logarithmic equations. Let's do one more, okay, before we start. These are so exciting. I really don't want to stop here. Let's make up one more problem. Log of, let's work on this problem. Log 2 plus log x equals 1. Now, I don't have just two logarithms and a 0 on the other side. If there's a 0, then I can move the logarithm to the other side and get rid of the logarithms on both sides. Now what do we do if we have something like this? You'll have to use properties of logarithms. You see, you have sum of logarithms, which is same as log of the product. Okay, so I'm using my product rule. Log of 2x is equal to 1. Now, this is similar to the one that we did just now. You see this one? Log x equals 3.67. So what we did was we changed it to exponential form. Let's go ahead and do that. The base is 10. Change it to exponential form. You get 2x equals 10 to the power of 1. And 10 to the power of 1 is 10. 2x equals 10, or x equals 10 divided by 2, which is 5. Done. Okay. I hope you enjoyed it and hope it was helpful. I'll see you all in the next video.